TRIAGE, role-typed credit assignment for agentic reinforcement learning by researchers at LinkedIn, Harvard, and Johns Hopkins. We are jumping right into the core insight for you today.
Oh, absolutely.
If you are training multi-step agents, standard GRPO is structurally incomplete.
Yeah, that's a bold claim, but it's true.
Right. It applies the final verifier outcome as a uniform advantage to all tokens in a trajectory. And this creates massive blind spots.
Huge blind spots.
It actively punishes useful exploration in failed rollouts. And, like much worse, it reinforces regressive actions in successful ones.
Which is exactly what you don't want.
Exactly.
Yeah.
So Triage fixes this by introducing a semantic role axis. It uses a structured LLM judge to classify environment-facing segments as decisive progress, exploration, no progress, or regression.
I love how clean that taxonomy is.
I know, right?
Yeah.
And by mapping these to bounded process rewards, Triage preserves exploration, suppresses regression, and significantly boosts success rates on agentic benchmarks.
All while cutting down the actual rollout length, which is wild.
It really is. Welcome to AI Paperslop, the YouTube series where we summarize and dissect the latest AI and tech papers for you. I'm your host, and today we're figuring out how this triage framework fundamentally rethinks credit assignment in RL.
Yeah, because to see why this rethink is so necessary, you really have to look at the underlying mechanics of standard group relative policy optimization, or, GRPO.
Right, especially when it's applied to a multi-step agent.
Exactly. GRPO has become incredibly popular lately. I mean, it's wonderfully efficient because you don't need to maintain a massive learned value model in memory.
Yeah, which saves so much overhead.
It saves a ton. So you give the model a prompt, you sample a group of trajectories, and you just wait for a final binary verifier reward at the very end of the line.
Like, did the agent ultimately succeed or fail?
Exactly. And then you normalize that advantage within the group, and you basically broadcast that exact same scalar advantage uniformly across every single token in the trajectory.
Okay, let's unpack this for a second. Imagine you are grading a massive group project for a university class.
Oh, this is a great analogy.
Right. So one student on the team accidentally deletes half the database on the final day.
A total disaster.
Utter disaster. But magically, the rest of the team pulls an all-nighter, they recover the data, and they ship a working application.
Okay.
Because the project succeeded, you, as the teacher, hand the database deleter an A+.
Which makes no sense.
None at all. And on the flip side, imagine a brilliant coder on another team who tries a mathematically valid but ultimately unsuccessful architecture.
Right. They did good work, but the project failed.
Exactly. The overall project fails, so that brilliant coder gets an F. Standard RL operates exactly like this.
It really does. It treats every single action in an agent's trajectory identically, based entirely on the final outcome.
Which seems so flawed.
That uniform grading is the root of the entire issue, because when an agent interacts with a web browser or a terminal, it takes dozens of discrete steps. Yeah,
it's a long sequence.
So a decisive action, a useful search query, a harmless pause, and an actively harmful edit, they all get lumped together. The authors actually refer to these as the conflict cells.
Conflict cells, okay.
Yeah. And relying solely on outcome credit gives you two systematic blind spots. First, highly useful segments and failed rollouts are fully punished.
Just like the brilliant coder getting an F.
Exactly. And second, regressive segments in successful rollouts inherit positive credit simply because the agent managed to, get lucky or recover later in the run.
The database deleter getting the A+.
Spot on.
I want to linger on what that actually looks like in practice, because the logs detailed in this paper are, honestly, they are both hilarious and deeply concerning if you're trying to deploy these models in the real world.
Oh yeah, the ALFWorld logs.
Yes. So there's a task in the ALFWorld benchmark where the agent needs to put a cool apple in a garbage can.
Simple enough.
You would think. But under standard GRPO training, the agent entered a 15-step loop where it just output the command examine fridge 1 over and over and over.
Just staring at the fridge.
Literally 15 times. Nothing happened. The physical state of the environment didn't change at all. Finally, it broke the loop, stumbled over to a cabinet, got lucky, found the apple, cooled it, and won the episode.
And because the final verifier flagged a success for the overall trajectory, GRPO took that entire run, including the 15 fridge stares, and assigned a positive advantage to every action within it.
Right. So the model essentially learns that obsessively staring at a fridge 15 times is a highly effective, strictly necessary strategy for winning.
It's reinforcing pure superstition.
Yeah, your policy gradient is actively being polluted by its own success.
which is exactly how sparse reward agent training becomes so brittle. And on the flip side, think about what happens to exploration under this paradigm.
Like when it tries to gather information.
Right. If an agent tries to gather information, maybe reading a directory structure or clicking a help menu, but the overall trajectory fails, standard GRPO tells the policy, hey, never do that again.
Wow, so it punishes curiosity.
Exactly. The agent learns to avoid information gathering before it even has enough information to act decisively. It becomes terrified of searching or reading.
So if uniform grading is the core problem, how does the model learn to distinguish between a useless loop of staring at a fridge and, like, a crucial search query?
Well, you need a way to categorize actions based on their causal role in the trajectory, but without completely discarding the final outcome.
And that leads directly to the triage taxonomy, right?
Yes. The authors introduce a semantic role axis to evaluate actions independently of that final success or failure flag.
And they define 4 distinct categories for this.
Right. The first is decisive progress. This is the obvious one. It's verifier checkable task state progress.
Like buying the target item in a web environment or submitting the correct final answer to a math problem.
Yes, exactly. If you achieve a clear subgoal, the credit rule assigns a strong, outcome-aligned process reward, a +1.
Okay, that makes total sense.
But then you have actions that don't immediately complete a subgoal, and this is where they introduce the exploration role.
Right, the E-roll.
Yeah. These are actions that change the information state without advancing the physical environment state, like inspecting a container or running a search query.
And exploration gets a conditionally positive reward, right? A +0.5.
Correct.
Wait, hold on. Let me jump in here. If an action doesn't change the task state, why does it get a positive reward?
That's the big question.
Because the paper also introduces a no progress role, which is basically harmless infrastructure or empty traversals, and that gets a slight penalty of -0.1.
Right.
And then there's the regression role, which is state corruption or those redundant fridge staring repeats. And that gets slammed with a -0.5 penalty.
Yeah, a heavy penalty.
So from the environment's perspective, neither exploration nor no progress changes the actual state of the world. They both return 0 task progress. So why is one rewarded and the other penalized?
The nuance there is the entire key to why Agentic RL is so difficult. Exploration isn't just a smaller amount of progress compared to a decisive action.
Okay, then what is it?
It's a fundamentally different type of progress. It improves the agent's belief state.
Oh, belief state. Interesting.
Yeah, and we have to remember that most agents operate in partially observable environments. If you are an agent searching WebShop or inspecting a massive code base, information gathering is a strict prerequisite to taking action.
Right. You cannot edit a file you haven't read.
Exactly. You cannot buy a product you haven't searched for.
So exploration changes the internal belief state, giving the agent necessary context, even if the external environment looks exactly the same to an outside observer.
Precisely. While no progress changes neither the belief state nor the environment state, it's just boilerplate text or empty movement.
Like scrolling up and down for no reason.
Yeah. And regression is actively corrupting the state or redundantly repeating something without any new information gain.
The fridge loop.
The fridge loop. By separating these out, triage gives the optimizer a causal map of why an action matters, even if it didn't immediately score a point.
Okay, so for anyone building agents, the implementation details are where this either becomes a massive breakthrough or a computationally impossible nightmare.
Oh, for sure. Compute is always the bottleneck.
Right. If you are calling a massive LLM to judge every single step of a long rollout, your training time goes to infinity. How are they reliably assigning these 4 roles during training without breaking the bank?
Well, they use a relatively small model, Quen 38B, acting as the role judge for each segment.
Oh, an AB model is pretty manageable.
Yeah, it's very efficient. And they give it a heavily bounded local context window. The judge sees the overarching task, up to 5 past actions, the current action and observation, and up to 5 future actions.
And crucially, the judge is entirely blind to the final verifier outcome.
Yes, that bounded window is a smart constraint.
Because if the judge saw the final outcome, it might be tempted to cheat, right?
Exactly. It might look at a successful trajectory and just retroactively slap a decisive label on everything, including the mistakes, just because the team won in the end.
A halo effect.
Yes, the halo effect. By restricting it to a local window, the judge has to evaluate the causal role of that specific segment purely on its own merits.
Here's where it gets really interesting. There's another critical requirement for the judge. It has to output a chain of thought evidence string before it assigns the label.
Yes, it can't just output a letter grade.
Right, it has to justify its reasoning based on the action history.
Right.
And once it outputs the label, that label maps to the fixed process, reward those constants we just discussed.
Exactly.
This design makes a lot of sense because it deliberately separates the semantic diagnosis from the overarching optimization direction.
Right. The GRPO outcome advantage is still there. It remains the base training signal.
So the role label from the judge just adds a bounded fixed process reward.
Yeah.
That reward is scaled by a mixing coefficient, usually called lambda, and then the whole thing is whitened within the batch before you update the policy.
Yeah, you've got the architecture down perfectly.
Yeah, but the paper makes a pretty heavy mathematical claim about this setup. They state, this role condition credit is the MSE optimal segment correction expressible from role labels alone.
What's fascinating here is how they frame it mathematically.
Yeah, they describe it as an L2 projection of the unobserved oracle advantage residual onto the subspace of role measurable functions.
I know that sounds like a massive wall of intense math.
It really does.
But the intuition behind it is actually beautiful. Think about the oracle advantage, like the theoretical perfect score an action should get if we knew everything about the environment and the optimal path.
The God's eye view.
Right. In reality, we don't know that perfect score. We just have a noisy guess from our standard GRPO advantage.
Because the environment is noisy.
Exactly.
Yeah.
The difference between our noisy guess and the perfect score is the residual. So when they say it's an L2 projection onto a role subspace, it means they're taking all that chaotic, noisy reward signal from the environment and forcing it to map cleanly onto our 4 semantic categories.
Because we constrain the reward to a known semantic category, we effectively strip out the random noise of the environment.
Yes. It is mathematically the most accurate correction you can make if all you know is the semantic role of the action.
That's incredibly elegant.
The fixed role constants directly reduce the advantage estimation error, assuming your judge is relatively reliable. And by mathematically reducing that residual error, you directly lower the variance of your policy gradients.
So you are giving the optimizer a much cleaner, significantly less noisy target to hit.
Exactly. It doesn't have to guess why a trajectory succeeded. It has a clean semantic label telling it which parts were useful and which parts were trash.
Okay, so the math checks out, and the mechanism avoids endless compute costs. Let's look at the real-world impact. They tested this framework across ALFWorld, SearchQA, and WebShop using Qwen 2.57b and Qwen 3.1.7b as the base policies.
Yeah, and these are benchmarks where agents notoriously get stuck in endless loops or fail to explore properly.
The success rate improvements are substantial across the board. But if you really want to understand the mechanics, you have to look at the ablations.
The ablations are where the real story is.
Definitely. They ran a test comparing triage to a scalar process reward baseline. This baseline uses the exact same Qwen 3 judge, the same local context window, but instead of outputting a semantic role like exploration or regression, it just outputs a generic floating point score from -1 to 1.
Just a raw number.
Right. And triage still beats the generic scalar score.
It beats it handily. And this proves a central claim of the paper, which is that Agentic RL specifically needs a role axis, not just a dense reward signal.
Because generic process scores conflate exploration with a lack of progress.
Yes. Because both actions result in a task state delta of 0. A scalar score just looks at a search query and says, well, you didn't win yet, so here's a 0.
It's blind to the belief state.
Exactly. While role typing says, you didn't win, but you gathered necessary information, so here is a specific exploration reward.
Let's go back to that agent staring at the fridge in ALFWorld. The ablations highlight that the biggest empirical driver of triage's success is actually the regression penalty.
Oh, this part blew my mind.
Right. When the authors audited the logs, they found that ALFWorld and WebShop have massive regression mass. In ALFWorld, 48% of the segments were regressive.
Nearly half.
WebShop was at 43%.
Almost half of the actions the baseline models take are regressive, and the fascinating part is that these aren't irreversible, catastrophic errors.
Right. They aren't deleting the database.
No, they are redundant reclicks. They are repeated observations. Suppressing regression inside successful trajectories is where the magic of this framework happens.
It stops the policy from learning that superstition we talked about earlier.
Exactly. It cleans up the agent's behavior immensely.
But there's a major catch with the judge itself, right? The paper found that if you use a no-think judge, meaning you prompt the LLM to output the label immediately, without requiring a chain of thought rationale first. The performance of triage actually degrades below the baseline GRPO performance.
This is a vital finding for anyone listening who is trying to implement LLM as a judge pipelines in their own architecture. The chain of thought step is non-negotiable for identifying regression hidden inside successful rollouts.
Why does it fail so badly without it?
If you look at the F1 scores for the judge in the appendix, the no-think model utterly collapses when trying to identify regression in a winning trajectory. It gets completely blinded by the halo effect of the final success.
It sees the win and thinks, hey, everything we did must have been genius.
That is exactly what happens. But when you force the judge to generate the evidence text first, when it has to actually describe the past actions on the current action, it suddenly realizes, wait a minute, this specific step was a useless repeat of the previous command.
It forces the judge to evaluate the local action, not the global vibe of the trajectory.
Beautifully put.
I can hear a lot of ML engineers listening to this and wondering about simpler solutions. If the core issue is just that we need dense segment feedback, why go through the hassle of an LLM judge at all?
It's a fair question. LLM judges add complexity.
Right. Why not just use standard PPO with a learned critic? Or train a shared backbone value head on the outcomes. Just attach a value head to the policy and let it learn the value of each state naturally.
The authors anticipated that exact pushback. So they ran a baseline where they attached a shared backbone value head, trained it on the same verifier outcomes using standard Monte Carlo returns, and added its per segment value increments to the GRPO advantage.
So what does this all mean? The results of that baseline are really telling. The value baseline improves ALFWorld and Search QA a bit, but it completely and utterly fails to move the needle on WebShop.
Yeah, it gets basically the exact same score as raw GRPO.
Why does a standard outcome trained Scalar Critic fail so fundamentally on WebShop while triage succeeds?
If we connect this to the bigger picture, you have to look at how a value head actually sees the world and what a regression looks like in the WebShop environment.
Okay, break that down for us.
In WebShop, you are navigating text menus to buy products. A very common regression is clicking an attribute you have already selected. Let's say you click the button for color.navy.
Okay.
The observation updates. Then, the agent redundantly clicks color.navy again. The text observation state returned by the environment barely changes at all.
Because it just reloaded the same exact page.
Exactly. So to the neural network, the input looks practically identical.
Ah, I see where this is going.
A statistical outcome-trained value head is just regressing Monte Carlo targets against the hidden state of that observation. It sees near-identical inputs for the productive click and the redundant repeat.
And because they both belong to the same trajectory, they both lead to the exact same final reward.
Right. The statistical value head credits them identically. It literally cannot see the difference. It is fundamentally blind to the causality of text-based action spaces where local observations don't change.
Because it lacks any semantic understanding of the action history?
Yes. But Triage's semantic role classifier is an LLM. It actively reads the text of the action history. It reads that you clicked Navy twice in a row, and it correctly tags the second click as regression.
That is the breakthrough right there.
Yeah.
Semantic role typing captures causal missteps that statistical value heads completely miss.
It really is. And because Triage successfully suppresses all those redundant actions, you get a massive efficiency gain at deployment.
The numbers on that efficiency gain are wild. Triage reduces the length of completed rollouts by 10.4% in ALFWorld and 14.8% in WebShop.
That is huge.
If you are running agents in production, that is a massive deal. If your agent accomplishes the task in 15% fewer steps, that is a direct 15% reduction in token generation costs, API calls, and latency.
Absolutely. By punishing the boilerplate and the regression, Triage forces the agent to be decisive.
It's surgical. You figure out what each segment actually contributed before you apply the credit, saving compute across the board.
Exactly.
To wrap this all up for the engineers and researchers listening, Agentic RL fundamentally requires distinguishing between exploration and no progress.
Without a doubt.
Standard GRPO simply can't do it, and outcome-trained critics are often blind to it in text-based spaces. Triage provides a principled, role-tight framework to achieve this.
Yeah, it uses a structured LLM judge to classify local segments, assigning them a bounded process reward while still keeping the overall trajectory-level optimization direction of GRPO.
You fix the structural blind spots without losing the overarching goal.
Which raises an important question about where this framework goes next. The paper touches on this in the future work section.
Oh yeah, the future work is fascinating.
Right now, this framework uses discrete hard labels. A segment is either decisive exploration, no progress, or regression. But what happens if we move to a soft roll distribution?
That feels like the massive open frontier for sparse reward RL. Imagine a probabilistic vector where a search action is rated as, say, 70% exploration and 30% distractor.
Because real-world actions are rarely perfectly binary.
Right. A query might reveal useful evidence while also pulling in irrelevant noise. If you could compute the credit as an expectation under a role-specific distribution, you could handle highly complex, mixed utility segments.
And as our base agents get smarter, these coarse failures like examining the fridge 15 times are going to naturally disappear.
Right. The models just won't be that dumb anymore.
Exactly. The credit assignment problem is going to shift to estimating fine-grained process rewards within these semantic boundaries. How do we judge the quality of exploration once all the exploration is at least baseline competent?
That will require judges that don't just categorize the role, but truly evaluate the magnitude of information gained within that role.
Definitely. But for right now, just getting the agent to stop re-clicking the same button and inheriting a positive reward for it is a massive leap forward.
It goes right back to that group project. We have finally found a way to reward the student who actually did the research and penalize the one who just stared at the fridge the whole time, even if they both end up with a passing grade.
It's about time.
It really is. Keep building, keep exploring, and we'll see you on the next deep dive.